Hello. Are we live? We might be. This is my first try on YouTube, so let me see. I think the audio seems okay. Let me see if I make this not sound terrible. Okay, I see nothing terribly wrong. So, I guess we're good to go. That was pretty easy. What do we have on YouTube? We have emotes. We've got okay, well, I guess let's just get started then. Let me get this so we can. What were we doing again? Oh, yeah, we were doing style transfer. I actually got started working on it a bit since last stream. Here, I can share the screen. There. Wait. There. Nice. Ooh, I should get rid of the follower thing. Okay, well, we're not sure we're going to stay on YouTube. We're just trial running it, so. It would be nice to have everything in one spot, though. Anyways, I was doing this. And when we left off, I tried to do this, and I didn't have my CUDA set up, and I didn't have pytorch installed. So I went and did all that, and then got started a little bit on it. So let me bring that up so that we can get going. I'm actually going to steal this. Let's see, where can I put this that makes sense? Can I pop out the chat? Nice. Nice. Okay, cool. That's okay. Yeah, that's much better. Now I can move this around. Cool. Nice. So you guys are gonna need to see not this, but also not this. We need to find, where did I put this? Tutorials. And then it's under style transfer. Okay, yeah. Actually, I should go one back. Then I guess we have to use VS Code. So let's do that. Okay. Normally I would try to set all this up beforehand, but we got sort of stuck in the rain. If you've ever been to Florida, you know how it is. Okay, cool. So we were, let me just go through this again real quick as a review, mostly for myself. But, okay. So let's see. Bringing in our imports, we're setting the device, and then we're seeing if, so sometimes you need to make decisions based on if the device is there or not, like the size of the image, since the CPU is just going to be way too slow if we try to do the full size image. At least for most people, excuse me, at least for most people, I guess. My CPU is probably a little overkill. Should be running these in the meantime. And then we're compose, so you do transforms.compose, and then we're resizing. And we're doing 2 tensor. Interesting that you have to do this. Interpolation mode bilinear, max size none. Okay, 2 tensor. And we're building a little image loader. Then we're going and getting the pictures we've downloaded. So we can open these. Yeah, so we got this picture and this picture, which if you notice, this picture is a little bigger than this one. So those are going to get resized. And we're doing this assert to make sure they're the same. And then we're building an unloader to transform that back to an image. And then this is some stuff because it's like an animated figure, plot figure. This will basically produce those pictures for us with the titles. And now they're the same size. And then we get the content loss. So we're inheriting from module, and then we're changing the initialization to detach the target because we don't want to train the pixels on the target. We want to train the pixels on a different imagery feed. And then we're doing the mean squared error on the input and that target. Then we're making the gram matrix, which I'm not exactly sure why we need to do that. It sort of tells us, but I don't know if it, I definitely didn't understand it all the way. So let's see. If we go here, I should be going here. So everyone can see it. Share with the class. Yeah, here. Make this bigger. Oh, it does the same page. If I have the same tab open on multiple monitors, it does. They both zoom in. That's weird. Okay. So a gram matrix is the result of multiplying a given matrix by its transpose. Makes sense? Okay, but why? It doesn't really say why. It just says, in order to calculate the style loss, we need to compute the gram matrix. Maybe that's just obvious, and I'm just too dumb to see that. In this application, the given matrix is a reshaped version of the feature maps. Maybe it's like canceling out the lines? I don't know. I don't know. That's a bad guess. Yeah, I'm not sure. But it's basically just it multiplied with the transpose and then normalized. Anyways, to figure that out. But once you do that and you detach it, so this is the style, you detach it for the same reason, take the gram, and then you do the same thing where it's just the loss on the target. So let's run these, and that's where I left off. So we're back. Let me see if I can find the code, so that's a little bit nicer. Just gonna look at it off screen and then we'll move it over. So we did the style loss. So let's see. Can I? No, that's terrible. Oh, it's even worse now. Dang it. I gotta get used to this. All right. So, importing the model. Now we need to import a pre-trained neural net. We'll use a 19-layer VGG network, like the one used in the paper. PyTorch's implementation of VGG is a module divided into two child sequential modules. Here, I think this is on this. Yeah. PyTorch's implementation of VGG is a module divided into two child sequential modules. Features containing convolution and pooling layers, and classifiers containing fully connected layers. We'll use the features module because we'll need the output of the individual convolutional layers to measure content and style loss. Some layers have different behavior during training than evaluation. So we must set the network to evaluation mode using eval. Yep. And then additionally, VGG networks are trained on images with each channel normalized by these and standard deviation these. Use them to normalize the image before sending it to the network. Okay. So we need to start by bringing in the model. Actually, let me just, so let's see, models.vgg 19. I guess they have multiple versions of them. Retrained equals true. And then features to device eval. And then let me just see what this is. So it's downloading the model, I guess. Let me make sure that we're using the GPU as well. Make sure we're doing this properly. Wow, this is gonna take a while, huh? Jeez. Well, after that, so note to self, downloading these models takes a bit. Interesting where it's putting it. It's putting in a .cache directory. Okay. So we need the mean and the standard deviation, and then we're going to make a normalization class similar to how we did the loss with an init and a forward pass to normalize the image with those parameters, which I guess you just have to know, or they're listed somewhere. You have to like do some due diligence on the model to make sure you have the correct numbers. And I guess you would recognize that if you, like, this is why you visualize stuff, right? Because otherwise, like, you need to tell that what you're doing is doing something correctly. Okay. CNN normalization mean. Tensor. Those numbers are I guess these are the three channels. 0.485, 0.456, not one, not insert, and 0.406. And then this is going to be different for the standard deviation, which is 0.229, 0.224, and 0.225. And then both of those need to be put to the device. Let me see if I can do this the fancy way. No? Nice. Oh wait, that's not how you do it. To device. Oh, whoops. That was my NeoVim commands to exit insert mode and save. Okay. So now that we've got the normalization stuff, we can make the normalization class that we're eventually going to put into the sequential model. Let's see. Eventually this will be downloaded. I remember that for the future. Do that ahead of time. Normalization. So everything inherits from module. Basically, and then we do this def init from self, and then we're going to pass it mean and standard deviation, and we're going to inherit that initialization from normalization itself, and then so we're going to inherit the normalization portion. And then we're going to add self.mean equals torch dot tensor of the mean. And then we're just going to reshape it. I need a better mental model for mapping for how view works. I would play around with it, except we're at 26% for our download, so. But we're going to do the same thing here. Standard deviation. Because why not? They're the same dimensions. And that should be our init. Except that I missed this. What? Why did it? Okay. Okay. Now, we need our forward pass, which is self. You give it an image. Well, I guess you give it whatever is in the step before it, but we're going to call it image. And then we just normalize it with our information here. So I guess what this view is doing is setting it up to broadcast? No, I don't know. That's a guess. So you subtract the mean, divide by the standard deviation. Okay. I like how it timed this out. So it's pending now. So this seems to make sense. But I want to see what this is doing exactly. What did I just do? Where am I? What the heck? Is this going like to the top? Yes. It's annoying. Okay. Okay. Why does escaping go to the freaking top? Okay, there we go. I want to see. I want to see this. I want to see what this does. It should be pretty. So, what do I think it's going to do? I think it is going to reshape, right? What? So it's going to need to go to every pixel, right? So this negative one is going to match the batch size? No. One. So the one on the right that's unviewed is going to just be this array like we have here. But then this one is going to make each one of these its own. That doesn't make sense. Let's just go whip this up. Learning the basics here. Okay. It's not really telling me anything. Okay. Need like an illustration or something. Okay, here we go. Flatten second and third dimensions of the original data. And this is changing a specific number. So this is going to make two sets of 12 instead of two sets of 3 of 4. So that means this is going to make as many dimensions as it can of one group of one. Yeah, so it's going to split it out into individual sets. So it's going to be 0.485 brackets. It's going to be brackets and then bracket around each one. I think that's what's going to happen. Okay. But until this thing finishes downloading, keep going. So now we need to do sequential. A sequential module contains an ordered list of child modules. For instance, VGG19.features contains a sequence. conv2d, ReLU, maxbool2d, conv2d, ReLU, yada yada. Aligned in the right order of depth. Aligned in the right order of depth. Okay. We need to add our content loss and style loss layers immediately after the convolutional layers they are detecting. Yeah, so we're just sort of slipping our layer into the right space. To do this, we need to create a new sequential module that has content loss and style loss modules correctly inserted. Okay, this is sort of a long one. So I can't see the model right now, but it's going to need, each one of our things is after a convolutional layer. So content layers defaults. So we want to look for so we're basically going to loop through the layers, look at the names, and then when we detect one, we're going to rename it to our default. Sort of like tagging them. Style layers. Defaults. Equal conv1 conv2 conv3. So we're just going to go through 5. Okay, so those are the layers we want. And I'm guessing it goes longer than that because it says 19. So then we're going to make our function get style model losses. So we need our CNN, normalization mean, normalization standard deviation, style image. Yeah, so we need the CNN, the mean, the standard deviation, the style image, the content image, the content layers that we're going to be targeting. There's probably more I can do with this, since this was made in 2015 and was only sort of transfer learning from a model that, you know, was trained in 2015. Style layers. Defaults. Okay. So that makes sense. right? We need the network, the mean, standard deviation, the style image, content image, and then the layers that we're going to insert after. So, normalization module. So we need to initialize our module, our layer for normalization that we built. Normalization equals normalization, and then you go to normalization standard deviation dot to device. Okay. And then just to record those, just sort of like logging. Just gonna initiate these arrays. 83%, we're almost there, sort of. So, assuming that the CNN is a sequential, we need to make a new sequential to put in modules that are supposed to be activated sequentially. So we're going to build a new model, basically. And we're going to start with a sequential with a normalization layer. And then we're going to add stuff onto that, I guess. So we start there, and then we begin our count. So we're just going to go through and go through each layer. When I say layer, does it sound like I'm saying like layer, like a cave? I don't know. Anyways, 90%. Man, that thing takes forever. Okay. So we can basically just go through each layer and then look for exactly whatever we are looking for inside of an if statement, inside of an if else. So it's like if you see the layer, is this the layer you want? If so, do a thing. So is instance layer. So if this is a conv 2D, then we're going to increment because that's what we're looking for. And then we're going to set it equal to the name that we had. We're going to number it because that's the formatting we did for our So that's the formatting we did for our lists up here. Okay. The in-place version doesn't play very well with the content loss. Oh, this is for Raylu. Okay. So we're going to do the same thing for Raylu. Else if. It's weird that is instance doesn't have an underscore. is instance layer compared to inin Relu. Also, why is Relu spelled so strangely? I mean, I guess it's just the abbreviation, but it's weird when you're thinking about like camel case or snake case or scout case or whatever. Oh well, it's used enough for you to remember, I guess. What happened? Where'd my... What the heck? How'd I get up there? This code is strange. Oh, maybe my self finished. So that's the case. So if it's a Relu, we're going to name it we're really just going to number it. We're really just going to number it. Yeah. So the in-place version doesn't play very well with content loss and style loss. We insert below. So we replace with out of place ones here. So the reason we're looking for Relu layers is because if they're doing it in place, it's not going to work with our style losses, or with our losses that we made. So we're going to change those to just in place, or not in place, opposite of in place. I actually just realized a cool thing is that we're going through, and each of these layers has attributes like name and layer. So here we're physically changing the layer that we're on, which is cool. Anyways, looks like this worked. Nice. So we can look at this. Okay. So maybe this will give us a better idea of what's going on, I would think. We're going through here. So it's got a conv, Relu, max pool. So we need to go through, and after every convolution layer, these are all in place, which we're changing to false. And in every convolution layer, we're going to add a content or loss layer, I guess. And here we're just naming it so that we can get the model we want. What is this weird coloring? What's going on here? So that makes sense. Yeah, it's pretty deep. Yeah, so I guess we only need 5 of the convolutional layers. And our CUDA was working, so that's cool. Okay, let's see if this works. I didn't do this one. Okay, so I was close. But also wrong. I did not realize it would put 2 of these around each one. So we're doing as many of these as we can. So we're doing as many batches as we can where they all have a single row and a single column. And I guess that puts the double bracket. I think that's what it is. Anyways, let's keep going. Let's keep going. we did the ReLU, and then we need to name the pooling layers. There's got to be a more efficient way of doing this, but I guess this works. Layer, and then max 2D. Then, so we're just going to change the name. Cool. Crap, I keep trying to do that. And then we also want to check for batch norm layers. What is wrong that it's yelling at me here? I guess I'm just not done with the loop yet. So we're going to name the batch norm layer. Just name it batch norm. Okay, and then catch all. Okay, runtime error. I do this. Layer dot class dot name. Yeah, so this is what I was saying, where each layer has its own attributes. Attributes is probably not what they're called, but that's what I'm going to call them for now. Okay. So then I think we're still, we're still in the for loop. Still in the for loop. We never left the for loop. Pete. Never left the for loop. Add module. Okay, yeah, so now we're looking through the children of the network that's being passed. But doesn't have commas. But our model is up here. Our model is just a normalization. But if it matches these, we're adding it to it to build our model from scratch, basically, but in a more automated way. So we add it, but if, right, and then if the name is in the content layer, which we defined here and passed here, then we're going to add that loss layer in. So we're essentially grabbing the model they had and slipping stuff in, but we're just doing it from scratch. Which is kind of how PyTorch works anyway, just how it makes it seem dynamic. So model, content image, detach, detach. Okay. Detach the content image, and that's the target. Wait, we're passing the content image. into the model we have and detaching it. And setting content loss. Content loss of target. Wait, so are we even slipping it in, or are we just running the loss function? No, we are. Yeah. So add module. Content loss. Should do this more uniformly. Wait. So we're going to name it content loss I. Content loss. Content losses. And yeah, so we got the content loss, and then we're going to add it to our list. We also added the layer to the model. Just add module is like append, right? It's not going to show me. Can I do this? No. That's really annoying. In normal Jupyter notebooks, you can like shift tab to get the documentation. There's probably a way to do it here, but it's not the same, I guess. So, if name in style layers. Target feature. So it's going to be pretty much the same thing. So we're running it through for the content image, and then we're running it through the style image. Touch. And the style loss of target feature. In the model, we're going to add the module style loss. See, this is why I like learning pytorch, because this is the stuff, when I was just trying to do fast AI, I didn't understand any of what was going on here, or that you could do any of this. I just didn't know how pytorch worked, which is kind of a prereq. But that's the prereqs, right? Module style losses and style loss. Okay, so each one of those is going to go through it's going to feed the model that we have up to that point. The image. And then it's going to add in it's going to get the loss. And then it's going to add the layer. Oh, I guess this is just getting the initial loss, because we're only doing this once. We're doing it when we build the model. I guess it's doing it once, but PyTorch like is constantly rebuilding models. it's like flashing the graph every time a change is made. It's like a frame rate type deal. So that's how we're getting the, so continuously appending it is how we're getting the cumulative array of losses, I guess. Okay, so we've done that loop to add all the layers in. I still don't know why this is yelling at me. Wait, did I put a JJ somewhere? Gee, what? Put the first one. Oh, that's just my formatter, I guess. I don't know. Anyways. We're out of the for loop. So now we trim off the layers after the last content and style losses. In range length model -1 because we index from 0. -1 -1. What is that doing? Visual Studio. Okay. So, model. Well, this isn't going to work, right? We're going to have to wait because our model isn't built yet. I guess it won't be as long as this is here, huh? Yeah, it's not going to work. Crap. Oh well. Oh well. I think I understand enough. So if is instance model I content loss or is instance, so these are just Boolean results, model I style loss. So we're going to loop through the model. Okay, so we're adding content and the style loss after the convolution. So after our last one, what? I feel like this isn't doing anything. Right? So this is not in this other for loop. Oh, I think I see. That's weird. Yeah, because it's the I that is set when you break is still going to be the value of I. I see. It's going to go up to that layer. So this is where the slicing happens. The whole point of this is to just get the right I. But wouldn't this stop before? Because we're setting content losses at each. item. So that somehow gets our last content and style loss. Now we need to just return model style losses. Which I apparently named wrong. And content losses. Should be like this. Yeah. I really don't see how this is. What's range? So range is going to take the length. Oh, it's going to reverse it. So it's going to count down and reverse it. Right? So if I do like if I do this. Whoops. If I do this, it does that. But the way range works, and we don't like VS Code. If I do this, it does nothing. Yeah, so this way, it reverses it and counts down. So this model is actually starting from the bottom of the model. It's weird that this doesn't. If I do this, it should count by twos, right? No. I already thought that's how it worked. Why does it keep kicking me out of the cell? Why does it keep kicking me out of the cell? Does this work? No. Oh, that's annoying. Okay. So this reversed it and started. Okay, so this is the index. And then this reverses it. I see. If I wanted to start from 5. Gotcha. Okay, I understand how range works better now. So that's its own reward. Let's run this. Did that. Despite all this yelling, it looked like it worked. I don't know why it's freaking out. But, oh, well, it didn't actually do anything. What? Yeah, I really don't know what it's freaking out about. But let's save this. Cannot forget to save, right? So let's see. Got all that. So next we select the input image. You can use a copy of the content image or white noise. Yeah, because it doesn't matter. I think it makes more sense to start with the content because I would think that it would train faster. Like for the noise to train faster, it would have to be closer. The distance between the noise and the content plus the noise in the image or in the style would have to be smaller than the distance from the content to the style. So I guess if you had a style that was incredibly different than the content, there's just like, I mean, even then though, you like if you had an image exactly the opposite of the content, I think it would still be, that's like noises. I think they would just be the same, right? Roughly. So yeah, I would just use the content. Anyways. And then we're going to do gradient descent. So do input image is the content image. And we're going to clone it so we don't mess with the original. Just plot it. PLT. Figure image show. Input image title equals input image. Nice. I don't know why it does this whole white business over here, but so now we're going to look at gradient descent. So as Lee and Gates, Gaddis, I don't know. The author of the algorithm suggested here we will use LBFGS algorithm to run our gradient descent. Unlike training a network, we want to train the input image in order to minimize the content losses, content style losses. Yeah. So that's good to note, is that this input image we're doing, even though we're setting it equal to the content loss, we've still got 3 images. We've got the content, the style, and the input. It just happens that the input here is our content, because what we just talked about. We will create a pytorch LBFGS optimizer. And pass our image to it as the tensor to optimize. I don't know why we need a whole function to do this, but it's setting the optimizer. This line is to show the input as a parameter. Oh, to make sure that it requires a gradient. So if we feed it to an optimizer, it will then take gradients over it, which is sort of, I think, why we were detaching the other images before, because we didn't want a gradient over them. So you don't want to change them. You just want to change this image. Input optimizer, input image optimizer, optim, LBFGS. No idea what this is. Turn optimizer. Okay, this thing. What is this? Can we do just do it? No, I guess not. Okay. Oh well. So finally, we must define a function that performs the neural transfer. For each iteration of the networks, it is fed an updated input and computes new losses. Right, so we're feeding back in the input image. You'll run the backward methods of each loss module to directly compute their gradients. Or to not directly, to dynamically compute their gradients. That makes more sense. Of each loss module to dynamically compute their gradients. The optimizer requires a closure function, which reevaluates the module and returns the loss. Okay, so what we're doing is we're running the gradients on the style loss and the content loss at the same time. So we're trying to optimize both the style loss and the content loss at the same time. And then we'll set weights on those to determine how we want the balance to be. First, we need to build this closure function. So we still have one final constraint to address. The network may try to optimize the input with values that exceed the 0 or 1 tensor range for the image, right? Which is what pytorch does. Can address this by correcting the input values to be between 0 to 1 each time the network is run. Yeah, so we can just sort of clamp things. Okay. Save. So when we run style transfer, we can do the CNN normalization. So we need to give it the normalization mean, standard deviation. So basically all the stuff that we needed for all the other stuff that we just did. Content image, style image, input image, steps. It's 300, which we could do more, but. And then, so here's where we set the weights, like I was saying before, which is way bigger than you would think. Right, so this is like doing it this way, just because I'm dumb. It makes things easier. That's 1 million. And then, so that's for the style. And then content is going to be equal to 1. Okay, so this runs the style transfer. So input building style insert model. That's what we did that other stuff for. And then this is not inside of a, okay, where's the, okay, here's the closure. I was wondering, you can't see that, but I found the closure. Found what I was looking for. Okay, model, style losses, content losses, bit style model and losses. CNN. Normalization mean. Normalization. Standard deviation. Style image. Image. Okay. So that will build our model and get our losses. So we want to optimize the input and not the model parameters. So we update all the required. We update all the required grad fields accordingly. So we're not updating the model. The model's pre-trained. What we're updating. This is like a different kind of transfer learning. Requires grad. It's true. And because we put our input image into an optimizer, it should have gradients. But the model itself, we want to not update because that's already trained. Wait. So why are we putting it through the optimizer afterwards? I guess anything with a tensor can have requires grad set on it. It's just saying track these numbers. Optimizer equals get input optimizer input image print optimizer. Okay. So let's start our iterations here. Run 0. See how they're doing this. Run center equal to the number of steps. Okay, so now we're going to build the closure. So closure is just a function that can take arguments from the previous namespace, I guess. Closure. Or does it take them? It uses them. So correct the values of updated input image. So this is where we need to do the clamping because otherwise it could overrun. Which, who knows how long it took them to figure that out. No grad. Clamp. Clamp between 0 and 1. Why does it say with no grad? And then we're going to zero out the gradients of the optimizer. And then we're going to run the input image back through the model. Style score equals 0. Content score equals 0. And then for style loss in style losses, we're going to set the style score. We're just initializing the style score above. And then we're going to set it. We're going to do the cumulative style loss, because we're just rebuilding this thing every time. And content losses. This equals content loss dot loss. Okay. Now, style score times equals style weight content score times equals content weight. Yeah, so then we're just scaling the score by the weights we set. And then we're just going to add those up. Wish we could have just put the weights down here, but whatever. Style score, content score, and then so we're adding those up, and then we're, man, AutoGrad is so sick. Plus, so now we're going to increment the run. So that's so sick. What it's doing when all you have to do is say loss.backwards, and then it will step back through all this math that we did. Which is pretty granular. We're taking losses from other places. And it will track this number backwards to these tensors. This input image tensor, which is here. To 0.theoptimizer. So it's tracking the loss back to the image, the picture. And it's taking the gradients. So in a second, we'll probably take a step. So let's just keep going, and then we'll see. So this is just some bookkeeping stuff. So mod 50 0. So every 50 steps, print some stuff. Run. Wait. It's quite annoying. I guess for this one I really do. So style loss of 4 decimal places. Content loss. Why is this? Why is this like this? Content loss. 4 decimal places. Dot format. Format with style score item gets into it and content score dot item. Just print an empty line. Okay, so that's just some bookkeeping, and this is on the closure still. And we're just gonna combine them, show. And this is them weighted. So this is really just our loss, our running loss. I guess that's why we did it this way, was to be able to do this here, which you wouldn't have been able to do if you just put them here. Although you could probably just print loss, right? And then here print them separately. Anyways. So that is, so that's not just, okay, yeah, so that's the closure. But while we're still in the while loop, we want to run optimizer.step. Yeah. So we're really just running the step, and then the step is running closure, because we're going to run this step every time. And we're going to run this closure every time, zeroing out the gradients, running the model, getting the losses, adding them all up, all that business. And then sometimes it's going to print something. And then, so after the final optimization step, we can do, the optimizer step is just taking a step along the gradient. And we're working directly against the picture. So it's just taking a step. It's taking each pixel of the picture and moving it a step according to the gradient based on the optimizer algorithm or equation or whatever. So we turn off, so we do no grad. Input image, and then we're just going to clamp in place one last time. 0, 1. Okay, now we can finally finish this this run style transfer, because remember, this is a function. We're still in this function. This is just doing everything. It's like our main, sort of. And, okay, and we're just returning the image. So this is weird because it's like each time you run it, you're doing a training. Whereas with a lot of neural nets, you train it and then you just have a model that you can run inputs through. You don't have to retrain it a lot. But with this, it's like you're training the pixels, which are you're treating as parameters. You're treating the pixels of your image as parameters that you're training every single time you want to combine content style. So that's interesting. It's like really turning deep learning into the Swiss Army knife it can be. So anyways, I'm going to take a quick break and then I'll be back in 10 minutes and we'll finish this up. We're almost done, and then we'll keep going. We'll find something else to do. Probably the paper from these guys that came out 2 years after this one, which I haven't read, but uh, helps answer some of the obvious questions that the 2015 paper leaves off on. Anyways, thanks everyone for hanging out. This is a ton of fun, learning a lot. I'll be back in 10 minutes. All right. Hope everyone had a good break. People know I'm still alive, especially the dog. Dog really knows I'm still alive. Anyways, we sort of cliffhangered this whole thing we were doing. So we're almost done. So output. So we can do run style transfer. There shouldn't be any issues because I just copied this from someone, but there could be because I just copied it from someone. Standard deviation, content, image, style, image, and input image. So this is the basic idea. We need the neural net to transfer from, so we don't have to do all the training every time. That would be much more complicated. I mean, it would be more complicated. The mean standard deviation that that thing was trained on, and then the content image, style image, the input image. The output should be the returned input image, which is the transformed image. Image show output title equals output image Sphinx gallery thumb. What? Anyways, I off. What's this? I on, I off. Oh, way up here we said I on. Yeah. It's like the iteration interactive mode. Okay. All right, what broke? Torch often has no attribute LBGFS. Okay. Did I forget to? Nice. Where did we put this? So after, something after that. Where is it? See, in Neovan must be so fast. Where the heck is it? Where do we set the optimizer? Did I like forget to do that? What the heck? What is it supposed to be? Did I forget to do it? Oh, I definitely did this. Or did I? Yeah, okay, here. Okay, I'm not crazy. This looks like what you're supposed to do, though. Optim LBFGS. Did I not import it correctly? I feel like hate how it does this. VS Code is the worst. I love notebooks. So there's Optum. I guess we just need to check if it changed. Let's see. LBFGS. What did I say? It's very memory intensive optimizer. What's it stand for? LBFGS. I did this wrong. LBFGS, not LBGFS. See, if I knew what it stood for, I'd be able to figure this out. LBFGS. Yeah, okay, let's try that. Local variable content loss. Reference before assignment. That's because content loss doesn't exist. Content losses. Got to be. Wait, why is it even losses at all? Score. What am I doing? I'm all over the place. Notebook, please. Okay. Is it working now? Oh, it's working. Sick. I just realized I forgot my water. I'm gonna run and get that really quick. Ooh, it worked. Sick. That's awesome. I'm gonna see if I have any pictures of the dog to run through this, because that sounds more fun. That's sick. Should probably try to figure out the proper way to change this into just like an executable, huh? That's sweet. I'll be right back. Water achieved. So you can see we got the style loss and the content loss pretty even. That's pretty cool. Let me see if I have a picture of any of the animals. Already loaded up somewhere. Pictures. Not really. I do have other pictures I can use. Let me see. I don't think you can do GIFs. That would be sweet. Yeah, no, I don't see anything. Let's try this. Where? Okay. Let's try just doing my screensaver. Or not screensaver, but background or whatever. So we make this instead of dancing, you can Picassoify kitchen lights. Did that not work? Did it not change the size properly? What happened? It should resize here. Obviously, it's not gonna work. All print statements. Why is it so big? Why is it not resizing it? Let's see. Okay. Oh, is it because of this border? Or is it locking the aspect ratio? How do I like crop it then? Indexing. Um, so what would I have to do here? So I need the image size. I want it to be after this unsqueeze. It's equal to so this is going to be just do it this way. So like this. No way. Just got a shape, right? This is going to be an attribute as well. Right. Okay, yeah. Okay. So it's 512 up top. But how do I get that third one? Just do no. How do I can I just do this? Nice. Okay. Input width equal to jet shape 3. Can I actually change this? Can I do like what is it? First one, second one, third one, and then do something like this. Nice. Okay. And I then do something like this times Just say trim off like 5%. Does this work? I guess it would need to be forward. Can I like, I do this? Doesn't work at all. Doesn't. This is probably not the right way to do this, but this is what I know how to do. That should definitely work. Crap. So how do I make this rounded? The easiest way possible. Okay, well, I think that worked. This is the problem here. Okay, I guess my eyes are swimming a bit then. And is this garbage? Okay. Trying to. Yeah. There we go. Nice. Let's just try 10%. Okay, cool. But it really needs to be whatever percentage gets you to 512. So what times this number? So it's like this, right? We're just doing algebra. Gets you to this. And this is x. So if we divide by this, well, we just divide 512 by this number. Yeah, 512 is what percentage of this? .52 whatever. And then we want that. Right. We want that divided by 2. It's going to go on both ends. That seems high. That's like half the picture. Right? Right? It should be somewhere around 10. Maybe not. Maybe this is just a gigantic picture. Let's try it. So let's try. Let's just say tests. And then this is going to be this. And then this is going to be 1 minus test. So here. Yeah, that's very skinny. but go here. Yeah, why is it so skinny? My math is wrong. What is wrong with my math? So the image we want is X percentage of the image we have. And then we want to trim that off from each side. What am I messing up here? Why am I dividing? Why am I not just subtracting and doing it that way? That seems smarter. Why am I doing int here? What am I doing at all? Jeez. So the overlap is this much from each side. So instead of this, what we want, so we have to do that, is to just subtract it. Or, well, I guess in this case, it's just to start there. And then in this case, it's to subtract it. This. That didn't work at all. What? Let's be integers. I mean, what did we do? Oh, it doesn't even do it. What does this end up being? 711. The heck? What the heck? Is it not like this? Or is it not like this? There we go. Okay, yeah, that looks less skinny. My percentage thing was not right. Sure. Okay. So let's take this and then say, so the image width, let's just say, this is not going to account for any underlapping, but underlapping is that a thing? So let's do this. Okay, so the overlap should work. And then the image should be, so I should be able to do that from intuiting it. First, second, third, and then overlap. Well, I guess it needs to be. Actually, I can just do it this way, right? Just go ahead and do that. Should be the same. Overlap through. Whatever the third is, because we index from 0 minus overlap and turn that into an int. We should be able to unsqueeze that. No. No. Tuple index out of range. What? What you talking about? What are you talking about? What happened? No. No. Tuple index out of range. What do you mean out of range? Can we not get the shape from this? Do I have to do it first? Can I put it here? We'll try. Well, let's just get it working first. Let me put this here. And then see if I can put it here. And this should be image size. Guess it doesn't matter yet. No. JPEG image file has no shape. God. Okay, what is happening? So maybe unsqueeze needs to stay here. Nice, that's what it was. I was overthinking it. I was overthinking it, guys. Nice. So now let's see. I guess I can't put it here because it's already there. Ooh. So now it should be sized correctly if there's an overlap. And that was all probably written somewhere already, but hey, it's what it is. So now we should be able to see if this can just go all the way through and Picassoify my background image. It should all be the same. That we should already have. I'm gonna redo all that. That's our input image, nice. I don't know why this works. I should look into this more, probably off stream, but we'll see. And then it should be as simple as just running this through. And then eventually I'll figure out how to change notebooks into executables. Nice. That's pretty sweet. I mean, we took all this code from someone, but we did, just type it all out. Like, there's so much cool stuff that just lives inside my keyboard that I just need to know how to coax out, That's sweet. How would I save that to like a JPEG or something, I don't know. It doesn't look too bad either. I wonder what happens if we like play with the weights, Where are weights? I guess we can just say style weight is less than this. 500,000 when we run style transfer. Let's try this. This is the right one, right? Yeah. Oops. Hope it doesn't just execute that. That's pretty sweet. Definitely looks worse, but man, that's cool. So what are we gonna do now? What are we gonna start next? Probably more things similar to this. This is definitely progress though. That's pretty cool. What's a cool style we could do? I don't know. I'll play with that later. Now let's save this. I wish I had a picture of the pupper, so that would be adorable. That was great. Let's see. I think there was a second one. Yeah, this paper. This paper I haven't read yet, but probably will like tomorrow or something. And this just lets you answer some of the questions that you would ask, like, how do you keep the sky from being terrible? Can you mix different styles of things? See, like here, you're getting some of the house on the, you're getting some of this style on the clouds. But if you mask over it, you can take this sky here and put it here, which is cool. And you can like change colors, HD. I guess not. I mean high res. And you can do like different masks. You can change intensity for background, foreground, or well, masks in general, I guess. So yeah, I'll read that paper later, but there should be code for it. Let's check that. Leon guidance. What? This is the author. Why does this one have more things? So there's a whole task tag for this. Includes course define high resolution. I never saw this one either. So what is this one then? So this is sort of combining the papers, I guess. Mm, FGS. Tends to get better results, but use more memory. Um, so does this not have all the code from this paper, I guess? Let's see. What I do? It's a very HD picture. This is Van Gogh. Okay. So this is the style transfer that we just looked at, I think. Except, you know. So where? Oh, so this is even more detailed. even change this a bit. Not really, though. Okay, so this is the high resolution bit. I wonder if this has... It said there was an advanced section. Not that I'm good enough to do the advanced section, but it said that one was under it. Okay. Dynamic decisions. Don't think... Man. Is this like a hidden... It's like a hidden tutorial? Again. Yeah, it's not even on this list. High resolution. I cannot tell the difference between this and this. Is that just my eyeballs? My screen is pretty big. I guess it looks a little better. Check my GPU memory size. Should know this off the top of my head, so. $14. That doesn't sound right. What? Why did it? I just want the specs. Okay, there we go. Founders Edition. Oh, 14 gigabytes per second. 8 gigabytes total. Okay. Gotcha. All right, well, let's move this over here and see if we can get it to work. So let's see if we can pick up where we left off with this one. So they leave off running the closure, basically run that function we made. Optimize our step closure. They clamp it. They move it back to the CPU. And then they plot it. I guess. They did it very differently. Well, at least in terms of, you know, the conventions they use, the naming conventions and stuff. This looks pretty good though. How do we, is there a way to like save this? First of all, let's change this to just this. Why not? And then change it here. And now, how do we save this image? What format is it in? Image show outputs. It's gonna be a tensor. Where's this image show function? Okay, tensor.cpu.clone. So we're cloning it, squeezing it. Okay, so we're doing transforms to fill image. And then we're doing show. So if I want to do this, but I want to do save. So let's see. Save tensor. Path. Motor. PLT save. Let me just save fig. Now image. PDF. Optimize depreciated. Quality is depreciated. So let's just say, let's see if we can just say save fig. And I have an example. Let me see if, how do we do this? torchvision.utils. Let's save image. Let's try that. It's handy. Makes sense because it's in utils. Save a given tensor to an image. Wow, nice. Okay. Save image, and then we just add that to our image save. So we add save the image to the path. And then I guess we should show. I guess we should do the rest of this as well. Change this to path. See if this works. Let's see, what do we call this? Output. Output to this data image gas chain. Picasso. It's not technically Picasso, it's just this one image by Picasso. Okay. Yeah, I didn't think that would work. Tensor or list of tensors expected. What? This should be a tensor. Yeah, That's not the problem. What is the problem? Is it because it's unloading this? Maybe we just don't need any of this. Hey, that sort of worked. It's got this like weird cross-hatching type thing going on. Cool. Why didn't it show up? I guess we need to do this after this, right? It's not. You know what it probably is. What the heck? I don't know what's happening with this. PLT.image show. Show. There we go. That's what I was missing. What if I don't do this? It's not as good, but it works. This is still here. Nice. You can sort of see the difference. It's subtle, but it's there. Okay, cool. Cool. So, back to trying to get this to work for what they were doing the other time. The precision thing. Now that this thing works, which is nice. Precision.utils. And then all the way down here. This might be overcomplicating things, but I guess we forgot to just do this. And then path equals data image. And then I can change this to whatever those names are. Nice. Cool. Now, to pick up where they left off, we're going to need, so make the high resolution as described here. It's described in their paper. So image size, high resolution, 100. So this is for the 8 GB GPU, which is what we have. And then prep. So prepping high resolution. It's going to be transforms. So we're making a new set of transforms. That's transforms scale. Size, high resolution. What does this do? Transforms that scale. I guess they're not going to tell us. All right, PyTorch, keep your secrets. Transforms.to tensor. And transforms.lambda. Is lambda, this transforms lambda just mean like we're going to pass this a lambda function? X. So we pass a variable and then that variable gets indexed. Oh, so we can make this tensor size from this and then index that way. 210. What? Okay. That all seems kosher. Turn to BGR. What does this do? I mean, you're not wrong. Did I just delete the top cell? Because... Okay. I guess not, because I went to edit mode. That's good. That's good. Okay. Okay. So, after changing each of those x's, not exactly sure what that's doing. We can normalize with the mean equal to, just gonna copy this over. Pretty relevant. Just gonna look this up whenever. Wait, what? Okay, okay, this needs to go here, first of all. Nice. Now, that's the mean. And then we're still missing standard deviation. Okay. That should be enough to normalize it. We're going to do another lambda. This time we're scaling it to 255. Are they scaling it to 255 because they're doing it with the cafe set? That would not work if that's what they're doing. You see their imports. I only see pytorch here. So that's good. Okay, well, I don't know what it doesn't like. That. Okay, that's what it didn't like. So now we've done that. I think that's scaling it up. I don't know if that's supposed to do that, but so prep high resolution images. Images, torch, prep, high res, image, like we just said, all the images. I might have to edit this a bit. If torch.huda is available images is variable image and squeeze zero huda. What is variable? This is what I get for jumping in halfway through their notebook. Images and torch images. So we're prepping it and then we're unsqueezing it, moving it to the device. And running variable, which I don't know what that is. Else, we're going to do the same thing, but we're not going to do CUDA. It's pretty much what you would think. And then, let's see, file image. Oh, they're just transforming them both at the same time. Just have to make sure it's in order style content. Reverse alphabetical, eh? Now, initialize with upsampled Lowers resolution. Oh, upsampled low res result. Opt image equals prep high resolution out image. So it's like we're running it and then we're running the out image. And then opt, is that output? Variable opt image type content image data requires grad equals true. I don't know what variable is doing. Let me see. Which one? Okay, we got like 15 minutes. Let's see if I can find what their thing is doing. It's part of AutoGrad. Interesting. Let's see. So this is just like an antiquated piece of PyTorch, I guess. It's very old. This is one of the downsides of using old stuff. But you also get to see where things used to be. It's cool. Okay. Well, we'll try it the way they have it. And then we'll just get rid of that stuff and see if it still works. Just get it working first, though. Okay. So we initialized with upsampled low-res results. Type as content image.data requires grad. So we just said requires grad equals true. Not sure we need to do that though. Like what does type as do? It doesn't matter. Probably does what it sounds like. Compute high-res targets. Style targets equal gram matrix. A detach A in EG style image. So I think they're doing things a little different. here. And then targets equals a dot detach for a and VGG content page content items. Get rid of this. So that's just detaching everything. I think they built their VGG different than what we have though. Style targets. Content targets. Okay. It's saying this should just run, but I really don't think it will. For a number of reasons. Let me look at their VGG. Yeah, they just straight up loaded the model. Yeah, I'm gonna have to go back and change some of this to make this work. Because this is the important bit. I'm not exactly sure how that translates. The other stuff I understand, and I think I could figure out how to translate. But let's see. This, I don't think this is gonna run. Yeah. Well, that's not a good reason for it to not run. What, no, that was wrong. It's this one, this one, this one. Images, torch. So what are their images? Images. So they basically made a list of their images. Okay, yeah. So the way they read their images in was not like this. So here we just did this. But they were a little more flexible. Image loader. So they said, first you want your directories, because they might not be from the same directory. But this is gonna like they're not gonna match up properly. But you could have multiple images in the same directory. Right. Image directory. Well, I guess you can just I guess you could do that too. You can do like import OS. And then you can say something dumb like okay. And then you say image directory is this, concatenated with this. Yeah. It should be. Right. Yeah. I guess I didn't need to do that. It's pretty confident in that one. I just do. I like saved. Okay. It's here. And then we can just say image dir. So from the same directory. And then they said similarly straightforward thing with the names. Yeah, it's just the names including the extension. Image names. I mean, I would make this like a dictionary and say content. I mean, it should really be much more strict than this. You should have like a content type and a style type. Like different classes to make sure they're always the same. You can't enforce this. You could just get these. You could just get this reversed. But you have the luxury of being able to see it, I guess. So. So let's see. They have it as style content, reverse alphabetical. So let's do that. And then let's do tonight's let's see, I would even do something like this is like the worst version of what I was saying. But still better than this, I think. This you could just get wrong. Well, you can, I mean, you can get the other one wrong, but this you can get wrong much more easily. But, I mean, they did a lot of cool stuff, so it's really just me trying to find some way to make some small improvement. Yeah, see, I just messed it up. It should be style and then content. Just because that's the order they had it in. Yeah. Okay. I guess these are, that's what was confusing me. Now that we've got all that, we can do wait. That's not even all of it. Why did they do it this way? Those are just the names. What a long-winded way of... Okay. This is how they wanted to do it, though. Images. So now they're doing open. I mean, this way works, I guess, but... Okay. Name. Enumerate. So this has the benefit of scaling a bit better, I guess. You'd still have to make this long list of things. Should just be image, not images. And then we're probably just going to go until we get this to be a different error, because it's probably going to have another error behind here. Right. But until then, let's see. Let's see. Where are we? That should be all the image names. And then, okay, so they're doing the prepping. But I think we're just doing that in our image loader, so let's try that. 0 style. Why isn't it running? Oh. It's trying to open both of them. Ugh. It's trying to open them. They're already open. As we're doing the loader here. I mean, I think I could just take this out. No. I think that worked. Actually, can I just do that? Sort of a long-winded way to have that get done, but I guess it works. Although their prep is certainly going to be better than my rudimentary thing here. Let's see if this works. Nice. Alright, well the rest should work from there, I think. So let's see if this thing is different here. Images torch. No, because they're doing other stuff. Prep. Okay, no, this might work. No. No, it did not. Doesn't mean invalid syntax. Let's prep HR. These are just image files. Torch images prep HR. It says how is that? I guess they're not. Their images are not. I guess my images are changed into torch tensors at some point. Images equal this. Images torch. Maybe I'm just trying to go too by the book here and not getting the spirit of the idea. Maybe reading the paper will help. The sense of it. Let's get this back to a. Is it doing the thing where it changes stuff not in the cell that I'm in? That would be annoying. Just changing stuff that's not even on the screen. I don't know why they made it do that. Like when I control C. I don't know what's happening. I don't know what's going on. I don't know what it's undoing. That should not have been too far down the undo tree. This looks cool though. Man, all right. Well, we got decently far. We got this sweet puppy. And yeah, we're gonna see how much further we can go. I'm going to be on tomorrow doing a study with me. I'm going to be on Twitch again on Monday, and then probably YouTube again on Wednesday, Friday, just to keep testing the waters, you know. Anyways, thanks for stopping by. I appreciate you. This was fun. I'm still super new at this, but this was fun. Yeah. Don't forget to subscribe, I guess, because it's YouTube now. But I will see you next time, hopefully tomorrow, if you want to hang out. Bye.